Here we are, AVID students, the third day of Chapter 1, Lesson 2. Okay, let's get our red pen. Earth's magnetic field. So right there, capital E, A, R, T, H, apostrophe S, magnetic, capital M, A, G, N, E, T, I, C, field, capital F, I, E, L, D. Switch back to my pencil. If you have ever used an orienteering compass, you have detected Earth's magnetic field. Okay, so an orienteering compass means like it's just a compass. The little needle on the compass spins and moves until it's straight with the north and the south. Earth's magnetic field is similar to the magnetic field surrounding a bar magnet. Like the bar magnet, Earth has a north magnetic pole and a south magnetic pole. The magnetic field lines fan out from the north magnetic pole, loop around, and come together at the south magnetic pole. Okay, a lot of information there, but basically this is what they're talking about. There is a north pole and a south pole. Now, it looks kind of weird to me. It almost seems like they're upside down. I'm not really sure about that. But the main point is that the ends are opposite from each other, and that there are these like invisible force fields that come out from the tips and go back into the other tip. So you've probably noticed this if you've ever had two magnets and you try to shove the ends together, they kind of push each other apart. But then if you flip one magnet over, all of a sudden they stick. That's because of the magnetic poles. All right, so what are we going to write? Let's see. Compass detects the magnetic field, right? Compass, C-O-M-P-A-S-S, detects, D-E-T-E-C-T-S, field, F-I-E-L-D. So a compass detects the magnetic field. And then there's a north pole and a south pole. So north, N-O-R-T-H, pole, P-O-L-E, and with line, 3 line, south, S-O-U-T-H, pole, P-O-L-E. Now notice that these are not capitalized, so this is not the North Pole and the South Pole of the Earth. This is a North Pole, meaning one end of the magnet, and a South Pole, meaning the opposite end of a magnet. Scientists attribute Earth's magnetic field to the presence of molten iron in Earth's outer core. So remember we talked about Earth's layers yesterday's notes? Well, here it comes. The molten iron core is helping create this magnetic field. Circulating electric currents are produced as the liquid iron core rotates. These electric currents create Earth's magnetic field. Okay, so molten iron outer core, circulating electric currents produce magnetic field. All right. So molten, and remember molten means it's liquid. M-O-L-T-E-N, iron, I-R-O-N, core, C-O-R-E, circulates, C-I-R-C-U-L-A-T-E-S. So that means that I believe it was the outer core, from our notes before, the outer core is actually liquid iron, and it circulates or it swirls around. Like if you have ever seen a lava lamp, it's kind of constantly in motion. Well, that circulating motion creates, C-R-E-A-T-S, notice I indented a little bit so I know that these go together, creates magnetic, M-A-G-N-E-T-I-C, field, F-I-E-L-D. So a compass detects a magnetic field, and it has a north pole and a south pole. That's what helps it spin and turn and line up just the right way. And then the molten iron core in the Earth is circulating, so we think that that creates magnetic fields, or a magnetic field. Okay, Earth's magnetic poles are tilted about 11 degrees with respect to the geographic poles. So what they're saying is, even though the Earth is tilted, remember last week we drew that picture of the Earth being tilted? The magnetic axis is a little bit different than that. So if the Earth is tilted, say that much, then the magnetic pole is tilted a little bit less. Moreover, Earth's magnetic north pole is near the geographic south pole and vice versa. Ah, okay, so because of the way magnets work, when you're talking about magnets, a north pole end of the magnet is actually at the south end of our Earth. Earth's magnetic field has reversed direction many times in the course of millions of years. Whoa. As you will learn later, scientists have used this fact to help explain how continents move. Huh. So the swirling molten iron core can actually change or flip magnetics. That would be really weird if you were walking along with a magnet and all of a sudden it switched. Now, it wouldn't happen that fast. It would happen over the course of probably thousands or even hundreds of thousands of years. So you wouldn't notice the change very fast. Okay, so what are we going to get out of this paragraph? Let's see. I don't want to confuse myself about the magnetic north pole being at the geographic south pole. So the magnet's north is actually at our geographic south. But I don't want to put that in my notes and confuse myself about that. Okay, the magnetic field has reversed, and that helps us know continents move. Okay. Field, F-I-E-L-D, can, C-A-N, reverse, R-E-V-E-R-S-E, little arrow, continents, C-O-N-T-I, oh, I'm running out of space, N-E-N-T-S, continents, move, M-O-V-E. So the magnetic field can reverse, and that has helped us understand how the continents move. Okay. Earth's magnetic field protects humans and other living things from the solar wind, a stream of fast electrically charged particles from the sun. The particles are guided by Earth's magnetic field into Earth's upper atmosphere near the poles. There, the particles collide with atoms and molecules of oxygen and nitrogen. The collisions produce beautiful ribbons and curtains of light, known as the auroras, or northern lights. Okay, so if you've ever seen movies where they show the aurora borealis or the night sky lights in like Alaska, for example, then that's what they're talking about here. So we know from previous chapters that the sun has a whole bunch of energy and light and heat coming towards the earth. But let's imagine the little tip of my eraser is that little bit of energy coming from the sun. As it comes, it gets to this magnetic field and it kind of gets attracted and moved down here to one of the poles. Or if there's a particle coming in up here, it kind of gets attracted to the South Pole. So part of the reason why we have life on Earth is because of this magnetic field. That's protecting us from all kinds of dangerous, harmful radiation coming from the sun. So, protects humans and other living things from sun's energy. Okay? Protects, P-R-O-T-E-C-T-S, life, L-I-F-E, from, F-R-O-M, sun's, capital S-U-N apostrophe S, energy, E-N-E-R-G-Y. So you know how it's dangerous to go to the beach and stay out in the sun all day long without any sunscreen because you get sunburnt. Well, that's all the charged particles and radiation from the sun that they're talking about. Now imagine if we did not have this magnetic field here, some of the energy that's getting deflected and shielded to the poles would be coming straight in and hitting us. So rather than getting sunburnt after half an hour of standing out in the sun, you could get sunburnt in probably 3 minutes. Very, very fast. So there's a lot of energy coming out of the sun, but we're also being protected and shielded thanks to the magnetic poles. Okay, let's look at our pictures. Like a bar magnet, Earth is surrounded by a magnetic field. Okay, do we have that in our notes? We have that Earth has a magnetic field, yes. And we know that the molten iron core circulates to create it. Okay. Auroras are common near Earth's north and south poles. Sometimes during extra strong bursts of solar wind, auroras may be seen as far south as California and Texas. Oh wow, that's pretty far south. Okay, do we have anything about the auroras? Let's see. Protects life from sun's energy. And, so line 3, line, creates, C-R-E-A-T-E-S, auroras, A-U-R-O-R-A-S. Okay, I'm going to go make the dog be quiet, and then I'll come back and we'll finish. Okay, let's come down here and answer our question. How is Earth like a compass? Okay, looking at our notes, Earth is like a compass because it has a north pole and a south pole, meaning it has opposite ends. Because its field can reverse and help us understand how the continents move. All right, now the visual summary. So remember, these are the big, huge, important things for this lesson that they want us to know. So we have to definitely make sure that this is in our notes. Okay, visual summary. I see the geysers. Hot springs and geysers are one sign that Earth has a very hot interior. Scientists have inferred that Earth's temperatures increase with depth, rising to nearly 5,000 degrees Celsius at its center. Okay, so do we have anything about hot springs and geysers helping us know that the Earth's interior is hot? Well, here's the chapter, Hot Inside. Let's see. Geysers help us know that it's hot inside. We drew a little diagram about the heat and the water and the steam erupting. And we also talked about how temperature increases as you get further down deep into the Earth. We use indirect evidence to make an inference. And then we can use experiments to understand even more. Okay, good. Earth has a layered structure consisting of a cold, brittle lithosphere, a hot mantle, and a dense metallic core. Okay, so let's flip over here to Earth's layers. Let's see, we need to talk about the lithosphere. Okay, we know that the lithosphere is a combination of the upper mantle and the crust. It's thin and rocky at the crust. Okay, we also know that the lithosphere is kind of like floating on top of the mantle, basically. A hot mantle. Okay, yeah, we just talked about the mantle. We know that that's kind of the in-between part, the meat of it. Like if we go back and look at the peach, we know that the mantle is the fleshy part, all that fruit that we eat, and the crust is like just the super thin little skin on the peach. And then it says a dense metallic core. So we know that the core is metallic. We know that the outer core is liquid. The inner core is solid. Even though it's super hot, we know it's solid because of all that pressure from all that material of the Earth squeezing down in on it. Earth's magnetic field is created by its rotating outer core of liquid iron. Okay, so we know about the rotating or swirling or circulating outer core of liquid metal. We have that down here in Earth's magnetic field. Where did we put it? The molten iron core circulates, creates the magnetic field. The magnetic field protects living things on Earth from harmful radiation. Okay, protects life from sun's energy and creates auroras. Sun's energy and, let's say, radiation, R-A-D-I-A-T-I-O-N. Okay. Now, there's always a little bit of radiation getting to us. Like, if you see the sun, then you see radiation. So a little tiny bit of radiation is just normal. It's always there. We don't even notice it most of the time. But what this is talking about is without the magnetic field, there would be so much radiation coming in, it would just sunburn us and cook us really fast. Okay, that is it for the entire lesson 2. Great job persevering. Good job using your pictures in your textbook, answering these questions on the pages, and then doing our lesson wrap-up to make sure we have the big ideas that we need. Good job, and roar Wildcats!